Let's see something good. All right, here we go. Okay, so again, we want to get a quadratic function. For the first one, we want a quadratic function whose vertex is -1, 3, and it passes through the point 3, 5, right? So we're going to get it in this form. HK is our vertex, right? And it passes through the point 3, 5. Okay, so here again, we have HK equal to this, right? So we must have H equal to -1 and K equal to 3. So we put it in. X minus -1 is the same as X plus 1, right? You know, plus K plus 3. Okay. But again, we have to figure out what A is, right? We have to figure that out. Now, how do we do that? Well, we know it passes through the point 3, 5. Okay, we know that. It has to pass through 3, 5. Okay, that's good. So in other words, this means f of 3 must be 5. F of 3 must be 5. In other words, when x is 3, we have to get 5 back. So this whole thing, actually, let me say this over here will equal 5 when x is 3. So that's what we have here, as you can see. And so from here, what do we get? We get a times 4 squared plus 3. And this is, of course, 16a plus 3. That's what we have here. So from here, we can figure out what a is, right? We have to solve for it algebraically. Okay, that's good. So from here, okay. Let's double check. I thought the microphone was off for some reason. So we want to solve it again. So we interchange both sides of the equation. I mean, really, I think it's more of a convention to have the unknown on the left-hand side. But technically, it's not wrong to have it on the right side, you know, because both sides are equal. So we have 16a plus 3 equals 5. So, you know, just like before, we isolate the unknown, right? Which is in this case a. Subtract 3 from both sides. The 3's here cancel. You get 16a equals 2. 16a equals 2. And so from here, 16a we get equals 2, right? But again, we want a. We don't want 16a, so we divide, right? 16 is multiplied by a. Now, excuse me, a is being multiplied by 16. That's better. So to get 16 off, we divide, right? And we get 16a over 16 equals 2 over 16. For some reason, let me write it in with a pen. Not sure why I forgot to put it in here, but it's not too big a deal, I guess. Right? So we get a equals 2 over 16, which I reduce to 1 over 8. Okay? So altogether, what we get, let me just see something. Yeah, altogether we get f of x is 1 over 8 times x plus 1 squared plus 3. So that is the quadratic function whose vertex is -1, 3, and it passes through the point 3, 5. Okay, I even sketched a graph just to illustrate that. Okay. Yeah, I could sketch it in Desmos, but I think seeing here, this is good. Right, so you can see it passes through the point 3, 5, and the vertex is -1, 3. That's the small. That's again where the graph changes direction. Okay. Hope that's okay. Any questions on this one? Let's do the next one then. So here we want it so that the vertex is 4 minus 2, and it passes through the point 1, 7. Okay? So again, we want a quadratic function whose vertex is 4, negative 2, and passes through the point 1, 7. Okay, so we have our quadratic function, right? So hk, which is the vertex, must equal to the point 4, negative 2. So again, that's not too bad, right? We have h is 4, k is negative 2. Okay, so from here, we can substitute, and we know so far that f of x is a times x minus 4 squared minus 2. Okay, so that's what we have here. But again, we're not done. We have to figure out what the a is. But that's pretty good. That's pretty simple to do, right? Because we know it passes through the point 1, 7. Again, what does that mean? That means f of 1 must equal 7. F of 1 must equal 7. So when x is 1, this whole expression, has to equal to 7. So we have this. So what's this right-hand side? Well, this is a times minus 3 squared minus 2. Which is, of course, a times minus 3 squared minus 2. That's 9 times a minus 2. Okay, you know, the a I put on to the right, like so. You know, even though a is a well, never mind. I don't want to cause more confusion. A does represent a number, so multiplication is commutative. That's allowed here. So we get 7 is 9a minus 2. We have to figure out what a is, right? Okay, it's not so bad, right? We have an equation to solve. Interchanging both sides, I do this. Okay, so let's get a all alone. We can add 2 to both sides, right? Because we want to isolate it, so we get 9a equals 9 when you add 2. Okay? So then we have 9 times a equals 9. But again, we want a all alone, so we divide. We divide both sides by 9. I'm not sure why it didn't come up here, but I just wrote it in. Dividing both sides by 9, we get a equals 9 over 9, which is just 1. So we get a is 1. So really, we don't write it. We get f of x is this then. Yeah?
Will you take off points if in the final answer, if we put the 1 in front of it?
Instead of leaving it off like this?
Yeah.
No, I won't do that.
Okay, thank you.
You're welcome. I mean, I know technically it's supposed to be left off, but again, I'm not going to get that, picky. So I'm not going to get that picky. Okay? So, you know, again, if by mistake you put the 1, if you did write the 1 in front, I'm not going to take points off. I wouldn't do that. Okay. Good question. Any other questions? Okay. And again, as a check, you know, I just sketched the graph. You can see that, yeah, the vertex is 4, negative 2. It does pass through the point 1, 7, which is what we expected. Okay. Good, good. All right. And I said this before, if you did graph it by hand, as you can see, the arrows here are not drawn, but I'm not going to take points off for that. I mean, I know they're drawn on the axes, but not on the actual graph. But again, I'm not going to take points off if you forget the arrows. Okay. All right, so that's the end of 3.1. What I'm going to do now is go on to 3.3, which is polynomial division. Okay. That's what we're going to get to now. Now, in the past, I would only cover synthetic division. However, I really want to cover polynomial long division. I think it's, useful. So, what the? I opened the wrong file? Oh, scared me. I thought I opened the wrong file. Okay, now it's here. Okay. Here we go. So this is 3.3. What we're actually going to see here is the division algorithm for polynomials. And that's what we're going to see here. Now, okay. All right. So here, the division algorithm for polynomials, what does that actually say? Well, again, if you have a polynomial f of x divided by a non-zero polynomial d of x, okay? Let's say we're doing that, we want to divide. Then it turns out there are two unique polynomials, q of x and r of x, such that f of x divided by d of x, right, will equal q of x plus r of x over d of x, which is equivalent to writing this. You just multiply both sides by d of x. Sometimes this form is a little bit better, but they're both equivalent, so it really doesn't matter which one you use. Here, r of x is either identically 0, the zero polynomial, or its degree is less than the degree of d of x. So that's what happens here.